Change. If there's any one single word that sums up our atmosphere, it's that. Change. From sun to storm. From frying to freezing. When it comes to the atmosphere, that life-sustaining envelope of gases which surrounds our home in the universe, change is it. And of all the ways in which our atmosphere is changing, none are more critical than those taking place in its composition, in the mix of gases from which it's made. Our atmosphere, the air which sustains us and so many other living things, is a mixture of nitrogen, oxygen, and other gases. During the Earth's long history, this mixture has changed dramatically. The air we breathe today is very different from that which surrounded the planet long ago. Its composition has been changing ever since the planet was formed billions of years ago. However, scientists now believe that the rate or pace of this change has increased dramatically during the last 200 years or so. This speed-up began with the birth of the Industrial Age and the accompanying increase in pollution that the ever-growing number of factories began pouring into the atmosphere. The atmosphere's composition has changed more during this brief span than ever before in human history. Unfortunately, many of these pollution-produced changes have been tremendously harmful. For example, acid rain, or as scientists call it, acid deposition. We've all heard how, in many areas, acid rain is contributing to the decline of forests and other ecosystems. Acid rain is, for example, making numerous aquatic environments so acid that many kinds of fish and other aquatic life can't survive in them. Acid rain is caused by harmful sulfur and nitrogen compounds. These pollutants come from three main sources. The first is electric generating plants, particularly those that burn coal with lots of sulfur in it. The emissions from their smokestacks are the main source of acid rain-producing sulfur. The exhausts of the millions of vehicles that take to our highways each day, plus emissions from our plants and factories, are the main source of polluting nitrogen compounds. Once in the atmosphere, these sulfur and nitrogen compounds mix with water to form both nitric and sulfuric acids. Later, these pollution-produced acids return to Earth as acid rain, snow, fog, dew, or solid particles, causing death-dealing damage to the environment wherever they land. And while talking about damage, look at this leaf. You don't need to be a scientist to see that it looks to be in awful shape. And that it is, the victim of ozone, another pollutant whose buildup in the lower atmosphere is causing serious problems. Ozone is a kind of oxygen. Its molecules form when three oxygen atoms join together, rather than the normal two, and it's a key ingredient of those lung-searing smogs that are so much a part of today's summer scene. Ozone forms when the sun heats the blend of nitrogen compounds and hydrocarbons our vehicles, businesses, and homes belch out into the air around them. But ozone pollution isn't just a city problem. Its damage isn't confined just to urban areas. Scientists are finding that ozone, often blown in from cities many miles away, is also harming a wide range of rural environments, many of which provide important food and cover for wildlife, along with valuable forest products and other resources. Ozone is, however, a chemical with a split personality. Here at ground level, it's definitely bad news. High above us, however, in the upper atmosphere, ozone shows its other side. Up there, It's a lifesaver. That's where we find a thin, fragile, and all-important layer of natural ozone. This crucial layer shields us from much of the sun's potentially deadly ultraviolet radiation. Without its protection, we would suffer many more cases of skin cancer and vision-robbing cataracts than is already the case. In addition, if the ozone layer did not filter much of the sun's ultraviolet radiation, many other organisms, ranging from bacteria to food crops, would suffer. Obviously, then, anything that threatens the ozone layer threatens us. And that brings us to the chlorofluorocarbons, or CFCs for short, pollutants to which, until quite recently, we've paid little attention. Introduced in the 1930s, for many years, CFCs were widely used in, among other things, refrigerators and air conditioners, and to make foam insulation, such as the kind used in food containers, cups, plates, and, until the late 1970s, as spray can propellants. As useful as they are, however, CFCs and related chemicals suffer from one terrible problem. They're murdering the ozone layer. The trouble starts when CFCs that have escaped in one way or another drift up into the upper atmosphere and mix with the protective ozone layer. Once there, the CFC molecules break apart, releasing their chlorine atoms. These free chlorine atoms then attack and shatter the ozone molecules around them, ravaging the ozone layer in the process. Chlorine atoms are such deadly ozone killers that just one can destroy as many as 100,000 ozone molecules. This attack is so harmful that many scientists fear that unless CFCs and related chemicals are completely banned, the ozone layer will soon be so damaged that it won't be able to protect us adequately from the sun's potentially deadly rays. So far, we've seen how changes in the atmosphere's composition are harming the environment. But as bad as the problems we've seen so far are, there's another change going on that may prove even more deadly. Simply put, many experts warn that the Earth is getting a fever, that our climate is warming faster than normal. Known as greenhouse effect, many think this global warming is caused largely by the buildup of carbon dioxide and other gases in the atmosphere that our widespread use of fossil fuels, such as coal, oil, gasoline, and natural gas, has produced since the industrial age began in the 1850s. Whenever these or anything else is burned, carbon dioxide is released. This and other greenhouse gases forms a blanket that traps some of the sun's energy, thus, many scientists fear, causing the Earth's climate to warm faster than normal. Just how fast this global warming is taking place and how far it will go is uncertain. However, scientists are now beginning to get at least some idea of what to expect. Rising sea levels caused by the melting of the world's ice caps and the flooding that would accompany it is one widely predicted result. Our agriculture could also suffer if abnormal warming made it impossible to grow crops where they once were. Our forests could also be damaged if global warming killed off those trees that could not adapt fast enough to a warmer environment. Well, there you have it. Change, change, and more change. The story of our atmosphere and what's happening to it. Acid rain isn't a pleasant story. Neither are ozone-damaged plants. Smog, a CFC-ravaged ozone shield, or global warming. They're not a pretty combination, but they're one we must face up to. The problems our pollution-changed atmosphere poses are tough, as are the cures for them. Cures such as a worldwide ban on CFCs and related chemicals. reducing pollution from our power plants, factories, businesses, and homes, developing fuel-efficient vehicles and similar conservation measures, and affecting alternative energy sources. Such steps are, unfortunately, likely to be both complex and expensive. But there's no escaping the fact that our planet has but one atmosphere. The air around us is all we have. Destroy it, and we destroy ourselves.